Hi, I'm Jasmine. If you're getting started with using a programming interface with your enDAQ devices, this is your first video to watch. So we'll go over using Python, how to access your recordings and its data, and we'll head to the code.
We'll go over how to open up your recording in Python and access all of its channels, subchannels, and some other info you can quickly grab. So first up is making sure the enDAQ IDE library is installed and ready, and then we can grab the IDE file using enDAQ.IDE's getDoc function and provide the path to the IDE. Now, since it's in the directory I'm working in, it's just the name of the file, but if it's not, you'll use the file path. And this would return a dataset object, and now we can check the channels. So we'll use enDAQ.IDE's getChannels and provide it this dataset object. So an optional parameter to specify is if you want it as channels or all their inner subchannels only. So if I switch the subchannels to false, there are just my 5 channels. And we can narrow this further with the measurement type. So if I want to just grab my acceleration, I can provide it a string here and get just my 2. We also have another option that rather than using a string, we can provide an enDAQ.IDE.measurement object. So I can replace a string with a full object here as pressure or acceleration again and get the same object return that we had before. So now, to grabbing some basic information, we can check out a dictionary of our sensors. We can also grab our channels again, and we'll notice this is a dictionary return unlike the list return from getChannels above. We can also grab the full file path using file name, and we can grab just the name of the file using .name. Alright, so accessing a specific channel, I'm going to grab channel 80 from the list return from getChannels, and that will be using indexing rather than keys. So channel 80 comes out of our list of channels as our second one there. So there's our channel object, and I can run some things on it like grabbing the ID number, we can grab the name of the channel, and we can grab the list of subchannels. Now, another alias for this is using our .children attribute to get the same thing. You'll notice this is a list unlike the .channels of an IDE that returns a dictionary. So another thing we can grab is the transform on the larger acceleration channels, which represent the conversion to G units from the accelerometer's units. So you'll probably want to grab the calibrations from the chip channels, which we'll go over in the next section right here. Alright, so accessing a subchannel is also pretty similar. We can grab a subchannel using the .subchannels list above, but we can also do it from our getChannels list had we not changed our subchannels to be false. So there's our subchannel, and I can grab the name, I can grab the ID the same way I had above. And this is, since it's a subchannel with an axes, this goes by 0, 1, and 2 for our X, Y, and Z. So there's our transform, and we get a specific calibration polynomial to our axis rather than our whole channel. And if you're looking to learn how to change the transform, you can watch our transforming data in enDAQ video next. Alright, so accessing more from the channels and subchannels, we can make sessions, which will be event arrays by calling getSession onto our channel or our subchannel. So if I print out a session, we have an event array, and I can change this to our X, and it'll be more specific and narrowed there. Alright, so some things we can grab. This will be the same for both of them. We can check the sample rate using getSampleRate. So if I change that to the X session, it'll be the same result. We can grab the interval of the recording using getInterval. And this returns our time range in microseconds of all of the acceleration recordings in this channel. And this will be the same return if you provide it the X channel. We can also check the number of events recorded within our session, which is 5,570 here, and this is obviously going to be the same if you call it on the X channel. Now we can grab our min-max values using getMin and getMax, and our first value is our time in microseconds, and the second is your value alone. You can also grab the mean using getMean. And now to the data itself. So I recommend watching our DataFrames video, but we can also view the data as NumPy arrays starting with our .ArrayRange method. So our first array here is our time series, which matches up with the interval time range that we called above. And all of our arrays following are our subchannels. So for X, Y, and Z. Now, if I change my session to specifically X, we will have just one array following the time series, only for that one subchannel. We can also specify the start time and end time that we want this data array to represent. So I'm going to narrow this down to 2.5 seconds to 3 seconds, convert it to microseconds when we provide it. And this will create just those values for us. Now I can also do the same thing with array slice, and rather than grab our subchannel values by time, I can grab them by index. So if I provide it just 0 and 2, I'll grab the first 2, and that should narrow it down just like that. Alright, and some other things we can grab will be our indexes near and before a time specified. So I can call get event the closest index to that number. If I want the number that comes before it, I can provide that and get the index right before this number happens.
Thanks for watching. I hope you found this useful. For similar videos, go visit and subscribe to our YouTube channel, enDAQ Technology, and happy coding.